come to this final section of the course where we discuss applications of derivatives uh, to real life situations. So, for example, this is an economic example where happiness of a person uh, is a function of the number of pizzas that they consume. And as you can tell by the curve, happiness rises up to a point, but then as you consume more and more pizzas on the same day, you are going to get less and less happy. But at the same time, the other there is the amount of money that you will spend on you have to spend to buy each pizza, right? So there is a function of a function. So we want to figure out how does our happiness changes with respect to the money that we earn. The more money that we have, the more pizza we can buy, right? But that doesn't mean that necessarily our happiness will rise. So we want to know at what point we'll be fully satisfied and with how much money our happiness will be satisfied on a given day. So there is two ways to go about this problem. One way is to everywhere we see this p here, we can substitute this e to the power of m. Let me use my pen here to show you that here we could say h of p could be written as t to the third multiplied by e to the power of m minus 1 and p plus another e to the power of m minus 1 plus a fifth, 1/5. And we can differentiate this with respect to m to figure out dh by dm. But that's a long way to do this. There's a shorter way that we can actually figure out the answer to this problem. What's the shorter way? Well, what do you think? We can we can differentiate the h function in h with respect to p first, so we may see some cancellations, and then we can only then at the very last bit can also different. But we can find what I'm saying is that we can find the h with respect to dp, and separately, we can figure out dp with the other function p with respect to m. The, so once we found this, what we are looking for is dh by dm. So we can multiply these two products with each other, and dp and dp here will cancel away, and abstractly we'll be left with dh over dm, which is what we want. So let's see what happens. What's the derivative of dh with respect to p? dh with respect to p, its derivative is negative 2/3 p plus 1, and this expression is dh with respect to p. dp with respect to dm will be just e to the power m, right? So when we multiply these two products with these two rates of change with each other, we should end up with dh with respect to dm. But there is a so if I write that out properly, I'll have e to the power m here plus e to the power m here again, and we can finally use a to eliminate this p here. We can use our expression for p, which was e to the power of m minus 1. So we could simplify this as e to the power of m minus 1 multiplied by another e to the power m plus e to the power m. Now everything is written in terms of m now, so can substitute any value and that you would be given, this should give you the rate of change of happiness with respect to the amount of money you earn at that point. Okay, so this was just a preliminary example, and I'll show you another few examples which might make it more simply simple. Okay, so in this example, we have been given area of a circle, which is a standard formula we all know about. So we were asked to, let's read the question, given that the area of a circle is a fixed value of a centimeters square and it's related to its radius r centimeter with this formula. What is the rate of change? What is the rate of change of its radius is given by dr by dt, which is 5, and we are to calculate the rate of change of area with respect to time when r equals to 3. So, how can we tackle this problem? Well, we can say that, okay, this dA by dt, know for sure because I know the expression for a is doesn't have any t's in it, but I can find the derivative of a with respect to r, and that would be 2 pi r, and I've been already given that what is dr by dt. So if I actually think about dA by dr and multiply that by dr by dt, what I end up with is what the question is asking us to find, dA by dt. Let me get rid of the writing here. So that's what we are going to do. So we know that the value of r that we need to substitute is 3 here. So evaluate this expression when r equals to 3, and that will give us 2 times 3 pi, which is simply 6 pi, and we are to substitute also dr by dt, which is 5 itself. So we have 6 pi for this section, the very first term, and dr by dt itself is 5. Therefore, we'll end up with 30 pi. 30 pi, we can put it in a calculator if we need a decimal answer, but that is the rate of change with respect to time at a particular point where r equals to 1, r equals to 3. Okay, so that's that expression, that's this example there. Show you another. Okay, so here we have yet another example of the derivatives. Let's read the problem and understand it carefully. It's asking us, it's saying that the volume of a hemisphere is given by the formula 2/3 of pi times r cubed, and the total surface area is given by 3 pi r square. Because it's a hemisphere, its surface area is actually 3 than rather than 6. This is a hemisphere. Okay, so that's why uh, this is not a standard formula for full sphere. Okay, so let me picture this for you. Hopefully, hemisphere is means half a sphere basically. So its surface area is actually, I believe they've added the area on the top as well, so that this is not looking like the standard formula. But in any case, let's read the rest of the problem. It says given that the rate of increase of the volume is at with respect to time is 6, find the rate of increase of surface area with respect to time. So this is what we want. We want to find what is ds with respect to t. But okay, so what is the how are we going to tackle this problem? We know for sure what's dv by dt, All right, and we can differentiate this expression here, v with respect to r. Okay, so somehow we can figure out from this expression what is dv by dr. That's fine. So that would be a piece of jigsaw that may be hidden. All right. So we can expressly write it out. So we have that in the back. So as you can tell from this expression for s, we don't actually have any t's in it. So, and we can find the expression for ds by dr somehow. That's fine. But how can we use this expression to come up with the rate of change of surface area with respect to time? Well, you somehow we're going to have to cancel away this dr and replace it with dt. How can we do that? Well, the piece of jigsaw that's missing is the fact that we do have dv by dt here. That's given to us here, and let's say 6. Okay, so we can replace that here. But okay, so somehow we need to get rid of this dr and this dv here. So how can we get rid of these two expressions on top and bottom of the fraction? Somehow, well, we did say that we can calculate dv by dr, and once we have that dv by dr, we can actually use its reciprocal. So take its reciprocal, and the reciprocal of that means 1 over it. Okay, so it would be dr by dv. So if we multiply this expression by dr by dv, okay, we get the cancellation that we want. This dr and dr will cancel away, this dv and dv will cancel away, and we get what we are looking for, ds by dt. All right, so okay, so let's go ahead and figure out what is dv by dr. When we differentiate this expression with respect to r, the power of 3 will come to the front, cancel away the denominator. We're left with 2 pi r squared. And once we take its reciprocal, we'll have 1 over 2 pi r squared. Okay, so we said we need to figure out what's ds by dr. ds by dr is 6 pi r, that's it. Power of 2 will go down to power of 1. And we already know that dv by dt is 6. So let's substitute these expressions over here. ds by dr is 6 pi r. And multiply by that by dv by dt, which is 6. And multiply that by 1 over 2 pi r squared. Okay, so this 2 will cancel away this 6 and leave a 3 behind. This pi and this pi will cancel away. One of the r's in the denominator will cancel away this r. So what we have is 18 on top of the fraction, and 1 r remains in the denominator. Now, we haven't been told exactly what the value of r is, but that's fine. That is what they have asked us to do. Um, we have done the best that we can do. So if in part B or C of the problem they do give us a value for r, we can evaluate this expression further and figure out exactly what's the rate of change of this area with respect to time is. Okay, so with that, I'm going to conclude this chapter, and I'll see you in the next bit. Hello, it's me once again. I've noticed that I've left another example out at the end of this chapter, so I'm going to go through this example with you before I leave this chapter and go to integration. So, let's read this problem and understand it carefully. It says that the head of the snowman has radius of capital R, and it loses its volume by evaporation at a rate proportional to its surface area. So, assuming that the head is spherical and that the volume of sphere is given by 4/3 of pi r cubed, and the surface area of the sphere is 4 pi r square, write down the differential equation for the rate of change of the radius of the snowman's head. Now, what the question is asking us is the rate of change of radius. It's not saying it explicitly here, but rate of change of radius means with respect to time. Okay, it's not explicitly given in the question, but this is what we need to figure out. So how are we going to go about and do this? Well, we're looking at our expression here. We can differentiate the volume with respect to r. That's fine. That's one piece of the jigsaw. That the jigsaw is um, uh, given to us here. dv by dt is inverse is of changes proportional to surface area, and area here is this expression for pi r square. So dv by dt here, we can just say that's negative k multiplied by 4 pi r square. Okay, so how does that help us to solve the problem? We have this fraction here, dv by dt, and d dv by dt. Okay, that's not bad. That's not bad. So what can we do to solve this problem? Okay, if we start playing around with what we've been given, we notice is that we can get some cancellations as we wish. That's fine. Once we find this, we can find this reciprocal and find the rate of change of dr by dv. Okay, so because we have dv here and dt is in the denominator is what we want here, that's a good thing, but somehow we need to get rid of this dv and get it dr in its place. So dr here is, if we take its reciprocal dv by dr, we get this nice cancellation that we need. So let's figure out what's dv by dr first of all. So dv by dr, by r I mean capital R, is going to be 4 pi r square, because the 3 as a power will multiply by the denominator, cancel that away, and it's reciprocal, therefore dr by dv is going to be 1 over 4 pi r square, and we need to multiply that by, so I'm just going to put it here, 4 pi r square, and dv by dt is simply negative k multiplied by 4 pi r square. And as it turns out, these two expressions are exactly the same, so we are left with a negative k, and that's the answer that we can give for the time being, because we haven't been told what's the value of k, right? Okay, so this is my take on differentiation. I'm sure there are lots and lots of other examples that I could have gone through, but at the time being, I think that will suffice for now. Please let me know if you need any other help or with any other questions.